Pull a pin on a grenade and this will happen. The blast radius is about 15 meters or 49 feet. Anyone within that space will be dead or critically injured. Pull the trigger on an M107 howitzer and anyone that is not protected in 100 meters or 300 feet will cease to exist. Drop Little Boy, a 5-ton atom bomb over Hiroshima, and in 10 seconds you will level 4 square miles and incinerate 80,000 people. It is needless to say that explosions are not fun, but some explosions are helpful, like the one that occurs in your car engine. As the spark plug ignites the fuel, it forces the piston down to propel the car forward, or the friction needed to ignite a match to prepare a meal. These explosions happen every single day and they help us. But can an explosion that occurred in 2007 be helpful for us today? Yes. How? It all has to do with this comet, 70P Holmes, discovered by Edwin Holmes in 1892. And since then, astronomers have kept their eyes on it. And then, on October 22, 2007, Holmes suddenly became brighter and brighter. So bright that for 2 days you could have seen it with a naked eye. The reason? The comet exploded. Possibly because of a collision with another comet, or most likely due to a buildup of gas inside of it. The explosion was the size of the moon. Then the blast radius was the distance between the Earth and the moon, and by November it was the size of the sun. So how does that help us? Comets hold a wealth of information and uses. They are leftovers from the formation of the solar system around 4.6 billion years ago. They comprise mostly of ice, rock, and gases. When the comet explodes, the ice is burnt away and there is a huge release of gas and dust. And in October 2002, this year, the dust from 70P Holmes will reach Earth. This dust is known as extraterrestrial matter, and studying it gives us a brief insight into the universe and what it is made out of. But how does that help us here on Earth? The dust cloud that is created from the explosion, it impacts radio communication. And as we cannot take a vacuum to space to fix the problem, once we start understanding the components of the dust, we can start making better communication devices. And two components of the dust particles are metallamine and ethylamine, or in other words, nitrogen, which serves as fertilizer for phytoplankton in the ocean. Phytoplankton makes up 70% of the Earth's oxygen. So when we breathe, we are benefiting from space dust. The other chemical compounds that are attached to the dust are in stasis. So studying them can give us an insight into what the planet looked like in its early stages. There is so much information that a team of researchers from the University of Leeds in Great Britain, led by John Plain, a professor in astrochemistry, has developed a new experimental simulator. It is called a Meteoric Abolition Simulator, or MASI. It can help us answer questions about comet dust and how it impacts Earth and everything on it. Until now, the study of comet dust particles and how it evaporates when it enters the upper atmosphere has heavily relied on theoretical calculation. MASI helps the researchers to see how silicon, iron, magnesium, sodium, calcium are affected when heated as they enter Earth's atmosphere, providing a better understanding of the upper atmosphere and the metal layer present there. The simulator also offers an understanding on the formation of planets and how the materials needed for life got there. One way that MASI has already helped us is in the designs of jet turbines. By better understanding the melting process of these different compounds, we can design ash-resistant jet engines which can fly without disruption through an ash cloud, similar to the one that is created when a volcano erupts. This is how studying these particles can help us. But there's a problem, a very small problem. The problem is so small that it is the size of a dust particle. 70P Holmes is not the first comet to explode. This explosion has been happening for millions of years. The solar system is already a very dusty environment, so much so that 52,000 tons of space dust fall to Earth each year. We may never be able to pinpoint a specific particle from 70p homes, but the particles that we are able to collect, it can help us in known and even unknown ways, furthering our understanding of the universe just a little bit more, thanks to some very helpful explosions.